In this demonstration, you will see how to configure storage spaces direct and to perform failover when one of the servers that hosts volumes used in storage spaces direct actually is switched off. So we're starting here in the Server Manager console. And what we can see here is we've got SEA, SVR 1, 2 and 3, and they're reporting in to the Server Manager console, but at the moment performance counters are not started. So what we're going to do is we're going to open up Windows PowerShell ISE, and we've got a script that's going to prepare everything for us. And we're going to step through the lines of that script. So the first one in step 1 is to basically go and install the appropriate roles and features. And this includes the failover clustering features and the file server features. So this will require each of these servers, SEA, SVR 1, 2 and 3, to actually be restarted. So they're being restarted and then we clear the screen. The next thing we do is we run a cluster validation. So to check that these servers are now in a state so that they can be actually added to a cluster. And of course, you should always validate a cluster before creating it. So although we get some warnings there, we're actually fine to go to the next step, which is to create the cluster. So we highlight the step 3 PowerShell. New cluster commandlet. It specifies nodes server 1, 2 and 3 and gives an IP address for the cluster. So we run that command and the cluster is created. Now that we know the cluster is created, what we can do is jump back to Server Manager and from the Tools menu, open up Failover Cluster Manager. And we go and connect to the cluster that we just created, which is called S2D cluster. Click OK. And Failover Cluster Manager connects to that cluster. So we've got a cluster there. Let's do something with it. So we jump back to PowerShell ISE. And now what we're going to do is we're going to enable storage spaces direct. So we run the PowerShell commandlet that enables storage spaces direct by running the enable cluster storage spaces direct commandlet on each of those servers. Once we've done that, what we need to do is we need to create the storage pools. So take all of the disks that are associated with those nodes and add them to a storage pool so that we can go and create the appropriate virtual disks. So we run that command and we create a storage pool that is accessible to all nodes of that cluster. And we can see here that it's called S2D storage pool. And if we jump across the Failover Cluster Manager and look under storage, we see under pools that we have cluster pool 1, which is that storage pool that we just created. Okay, now we've got a storage pool, we need to create virtual disks on the storage pool. So we use the new volume storage pool friendly names S2D pool commandlet that runs against those nodes in the cluster. We jump back to Failover Cluster Manager, and if we click on disks, we can now see that we've got our cluster virtual disks. They're in an online state and they're assigned to the cluster shared volume. So now that we've got our volume, we need to create a file server that can be used to share those volumes in a highly available state. So we run the new storage file server commandlet, and then we come back to Failover Cluster Manager and we go to roles and we've got S2D SOFS, which is scale out file server, and that's now configured as a highly available role. So the final thing we do is we go and create some file shares for that scale-up file server. So we run the PowerShell that goes and does that. It creates a directory, it creates an SMB share, and then it creates an SMB path. We go to shares, and we see that we've got share VMO1. So if we now navigate to the scale-up file server, S2D SOFS of VMO1, we've got access to that share. What we'll do is we'll create a folder in that scale out file server share called VM folder. So we've got a folder in that share. The next thing we're doing is we're going to stop one of the cluster nodes. This is to prove that the scale out file share is indeed highly available. So we stop SEA SVR3. We can go back to the mounted file share and we can show that we can still interact with it, We can create an example text document verifying that this share is still available even though one of the nodes underlying it is gone. And then if we come across to disks, what we can do is we can verify that it's noticed that that's actually problematic. So if we look at the health status of that cluster shared volume, we see it's in a warning state. Because two of the nodes are available, one of them's gone, and the operational status of that cluster